Hello everyone. Today I'm going to present my simulated self-learning module. I created a self-learning website for primary school students. Instead of just memorizing formulas, students will role-play as little architects. They must accurately calculate the areas of different rooms to buy the correct amount of floor tiles for a client. This transfers abstract math into a fun, engaging, and practical mission. The module has three learning objects. First, concept of area. Students will define area as the size of a surface and successfully differentiate it from lengths and parameter. Second, calculate basic shape. Students will apply mathematical formulas to accurately calculate the area of standard squares and rectangle. Third, spatial reasoning. Students will utilize cutting and rearranging technique to deconstruct complex L shape into simple rectangles. To facilitate independent learning, this entire module is hosted on a custom Google site. This is my website. It integrates YouTube video for conceptual instruction, PHET, and GeorgeBeth for simulation-based inquiry, Google Form for assessment. The learning journal begin with phase 1 basic training. Before taking the engineering challenge, we must fill in any knowledge gap. Students watch the YouTube video titled What is Area? This direct instruction visually define key terms, ensuring that students are fully prepared to interact meaningfully with the advanced simulation in the next phase. This video will explain the concept of area, and it will teach students how to calculate the area. Now we move to phase 2, which utilizes simulation for STEM inquiry. The first simulation used the free online source, the PHET area builder. Here students transition from theory to active exploration. They draw and drop unit squares onto a graph. By physically place these tiles, they visually construct how length multiplied by width equal to area. The simulation also features a game mode when students challenged to construct unique shapes that meet specific area and parameter target. If they make a mistake, the simulator provides instant feedback, encouraging trial error and self-correction without teacher intervention. Once they master simple shape, the en- engineering challenge get hard. Not all rooms are simple squares. What happens when the client has an L-shaped room? I have included a self-developed judge bed simulation focused on cutting and rearranging. Let me demonstrate how it works. In the interface, students are presented with an irregular L-shaped floor plan. They use slider on the screen and they draw the slider. The complex L shape visually breaks down and splits into two rectangles. They calculate the area of the two rectangles and add them together to get the total floor area. Once they have calculated that the total area, they can click here to see the answer. After simulation, the learning loop is closed in phase 3 assessment. Students must prove their ability by answering multiple choice questions. When the student complete the quiz, they can click the submit and student can immediately see the score and can see the correct answer. How does this module integrate engineering and mathematics? On the mathematics side, students are learning core area concept, unit measurement, and calculation formulas. On the engineering side, they applying this math to solve real constraint, estimating building material, avoiding waste, and fulfilling client architectural requirements. Ultimately, this integration leads to achievement, fostering deep confidence in STEM for integrated self-direct learning. This is my presentation. Thank you.